Thanks TT, thanks Core Studios, thanks New York for having us out here today. I'm excited to be here in New York. This is the first time I've been out here in 20 years, so thanks for welcoming me. My name is Gillespie. You may know me because if you downloaded the Rhino eval or you've ever crashed Rhino, you may have gotten an email from me. So if my apologies to everybody who's not going to get those emails while I'm giving this talk. I'm happy to see some familiar faces here today and get to meet others of you for the first time. I love this community of people that have grown up around solving geometry problems, data workflow, and other problems in this industry. And I'm here to talk about 3 new technologies that we've been developing really recently that we're opening up as open source projects. You'll notice that every slide on this in this deck has torn edges on the side. That's because everything that we're working on is really rough right now and really new. Some of it barely stands up, some of it barely works, and I'll sort of outline some of those things as we go on. These slides, on the other hand, may make it look a little more shiny and finished, so ignore the shininess of the slides. All right, so the first piece of technology. Have you ever wished that you could do something like this? So if you're a .NET developer, if you've ever written plugins for Rhino or Revit, this is a little piece at the top of the source code that you would use if you were able to write code that used the Rhino API, the Revit API, the Grasshopper API, all at the same time, all in the same file, all in the same process. So far, nobody's been able to do that. There's not a lot of code here, but we've actually got this working. And it's up on GitHub. It's a project that we're calling Rhino Inside. It's a way to make a plugin for other products, make Rhino be a plugin for other products. Here's a little video that looks a lot like some other things that you've seen, but it's not quite the same. So this is a Grasshopper definition. Wow, that's not really visible. This is a Grasshopper definition with a C# component in it. The C# code here, which I can't even read from here, is the code to take surface from Rhino and put it into Revit as a topography surface from this Grasshopper component. So we're going to reference a little surface here in Rhino, and then you can see the Grasshopper remote control there over on the right, and the Grasshopper remote control is controlling the surface, and you can see the topography surface over there on the left. If you could read this a little better, oops, dang it. If you could read it a little bit better, you'd see that this is actually a native Rhino piece of a native Revit object. Now, what's different here is that Rhino's not actually running as a process. Okay? So instead of having Rhino running somewhere, Revit running somewhere else, and then there being this interop communication thing going on, we've actually got Rhino running as a plugin inside of Revit. So there's a lot of the complexity of how you would interoperate between these products sort of taken out of it. I'm going to let this video run a little bit longer so you can see the stuff update. And I won't try pausing it this time. There's a point here where we're going to start editing control points, and you'll see it a little bit more, because you can't really see from your distance the topography surface updating. So now this is just direct manipulation of the surface in Rhino going in through Grasshopper and into Revit. Okay, so like I said, if you were to open this up in Task Manager, you'd see no Rhino. You'd only see Revit running here. So the first step in making this happen has been a long time in the making, and it's actually been a lot of work. But the first step is splitting Rhino apart. Recently, we figured out how to split Rhino into a DLL and an executable. For those of you that are programmers, you know what this means. And this makes it possible to take Rhino's smarts, optionally throw away the user interface, and inject it into other applications. So imagine Revit here now, over on the left. That bubble you can consider to be Revit's process space. Okay? That's the executable of Revit running. When we inject Rhino into Revit as a plugin, You now get Revit's APIs, Rhino's APIs together at the same time. And along with it, you get everything that those bring with them. You get Grasshopper, you get Rhino's plugins, you get Dynamo, you get all of those different pieces, and you can mix and match however you want. You also can do Python scripting. We've got several different versions of this running. There's one where, like you saw here, where you see the Rhino and the Revit user interface at the same time. We've also gotten one working where you just see Grasshopper running in Revit. We've also got one where you don't see Grasshopper or Rhino at all, and you can just click a button and solve a Grasshopper definition and put the Rhino, or put the geometry into Revit. A few people back home wanted me to make sure to say that we're not preparing to sell the Autodesk. So on GitHub, there are some samples of running Rhino inside of Revit and AutoCAD and a little console application. And I bet you can find some other useful places to put Rhino inside as well. The sky's the limit here as long as there's a .NET SDK inside that application. Kike Garcia is here in the audience. Find him a little bit later if you have detailed questions about how to do Rhino inside programming. You can also talk with me or any of the rest of us who have compute shirts on, which is none of us. Oh yeah, and all this stuff is up on GitHub, so check this out. The code's not very long, actually. All right, so Rhino Inside is number one of 3 of these pieces of technology that we've been playing with. And so now I want to show you something a little bit different. First, a little history. Rhino grew up as a companion product among monolithic CAD applications. In those days, everybody wanted to share their data with each other just like they do today. But when everything was big CAD applications, everybody talked to each other with big files. And so we've done a couple things for as long as we've been around to make that possible. First, the OpenNURBS toolkit has always been available for third parties to be able to read and write Rhino files well. And we've spent a lot of time supporting a whole bunch of different file formats inside of Rhino so that you can share your data everywhere you want. But files and monolithic applications don't fit the way people want to work today. Files are becoming object streams, document sets are becoming data flows, teams are getting huge. We're writing apps for everything, and monolithic applications make this hard. So we've been wondering how we can help. Over the last few weeks, we have been working on an open source geometry library that we're calling Rhino 3DM. It's available in JavaScript, CPython, .NET, and C++. It runs in all the major browsers. It runs on Node.js, runs in Linux, iOS, Android, and we think it even runs on Raspberry Pi. It's all up on GitHub. So what it lets you do is to create all of the objects and other pieces of information that you can put in a Rhino file, including points and point clouds, NURBS curves and lines, arcs, circles, etc., surfaces, solids, meshes, dimensions, text, layers, viewports, materials, all this stuff you can create with Rhino 3DM. And soon you'll be able to create sub-D objects as well. These objects exist outside of files. Each object has its own ID, and it can have any amount of data attached to it. You can save objects to binary blobs, in this case from Python on Linux. You can store these blobs on your favorite blob stores such as S3 or any of the other cloud services, or save them to your local disk, or put them in a database or whatever. And you can read that data from the binary blob here in Chrome using JavaScript in a web browser. You can also save many objects to a 3DM file. Here, for example, using C# on the Mac. And you can read those files into Rhino, or any other product that reads Rhino files, or into Rhino 3DM running on any of these other platforms that I just talked about. So what I'm trying to say here is that all of these objects are compatible across platforms, across languages, across everything. We're trying to make it easy for you to share geometry and data. Also, along with this, our mathematicians are releasing some things that they think are simple and the rest of us think are hard, like doing vector objects, vector math, matrix math, geometric transformations, NURBS curve and surface evaluation, polygon mesh topology, 3D spatial decomposition for rapid locating of objects in space. And this is what it takes to do it. In Python, you can just pip install Rhino 3DM and start creating geometry. I want to mention on the Python side, this is running in CPython. So for those of you that want to do analysis using something like NumPy or SciPy, other CPython libraries, this is your thing. You can get at the geometry, you can get at all the data, and do whatever analysis you need to do. I'll let you use your imagination. We also cross-compiled OpenNURBS to WebAssembly. Here's the code to fetch a 3DM file from a URL on the web and load it into Rhino 3DM. I'll need this a little later for one of the samples that I'll show you. This runs in all major browsers and also on Node.js. I think you can, I didn't add the code for this, but sometime in the last 12 hours, we had the ability to do, what is it, node install Rhino 3DM. What is it? Yeah, you got it. It's on NPM. And we've actually always had Rhino 3DM, well not always, the last 5 years we've had Rhino 3DM IO available, which is the .NET version of this. Maybe someday we'll rename it to Rhino 3DM.NET for consistency. And the syntax that you already know in Rhino Common or for inside a C# component in Grasshopper is the same syntax you would use to generate geometry standalone in .NET. So most of these things are projects of wrapping up OpenNURBS into these other languages. And I want to make a note about how we do that. Like I said, a lot of this stuff is really, really new. It's barely standing up. We figured out yesterday that sphere objects, for example, because they're not the same thing as BREPs, don't have the encode functionality hooked up to be able to send them back and forth yet. Maybe that'll be there in another 6 hours. Steve's working on it. But we prioritize sort of the obvious stuff first, and then the things that you ask us about. So, you know, maybe spatial decomposition won't come along unless you ask about it for the hackathon. And I've touched on this a little bit already, but I want you to realize that none of this is new. The OpenNURBS library, which I talked about a while ago, has been around for 20 years. It's what we use to read and write 3DM files. And so all the stuff that we're doing in JavaScript and Python and .NET is based on all the same file reading and writing stuff that we've been doing forever. It's stable, it's solid, it's been really well debugged. Okay, so you can create and share geometry, that's pretty fun. But what if you want to do complex computations with geometry, say using web requests over the internet? Maybe it'll be known as geometry as a service because, you know, the acronym. We're calling it Compute. It's a RESTful web service that does geometry computations. You can do things like create meshes from surfaces and solids, intersect things with other things, perform Boolean operations. If you're familiar with Rhino Common, everything that's in the Rhino geometry namespace is available now for you to call on Compute. And soon, we hope to be able to solve Grasshopper definitions in Python scripts, convert between file formats, and let you add your own plugins. The Python libraries already exist on PyPy. You can just pip install compute-rhino 3DM. There's been some discussion already about why it doesn't always start with Rhino, so maybe we'll change that. The JavaScript client libraries are already on our content delivery network. These are the links to the latest builds. I'm sure you can read that from where you are. Eventually we'll have links to specific stable versions that'll never change, like all the other JavaScript libraries that are out there, and we'll make it easy for you to find them and use them. And for .NET, you can use NuGet to get Rhino 3DM IO and Rhino Compute. There's libraries available. Actually, rhinocompute.cs comes off of the Compute website for now. There's no NuGet package. Okay. So Compute's already running on our servers. You just need to get a Rhino account token and try it at compute.rhino3d.com, or you can spin it up on your own servers. And we have no idea how licensing is going to work for this. Rhino 3DM is always going to be free. So if you need to create geometry and share it around, that's always free. Rhino Inside requires a Rhino license because Rhino's running. And Compute, we'd like to hear what you think works best. We want to come up with something that's fair and works well for everybody. So come find me, let's chat if you have ideas about how you'd like to license it. So let me show you a couple examples about how this thing works. Let's see, I have to click here. Do I have to do it this way? Okay, so oh, really? Apparently you don't. Oh, okay. So this is, thanks. This is an example that's using Rhino 3DM and a web browser canvas. There's no 3JS here. Steve just cooked this up yesterday, I think. Okay. And this one, look at all that. I may put some breakpoints for you later. This is an example of using compute. This is actually up there on our website already. So an overview of what this thing is going to do. This is actually using 3JS. This is using compute. And the idea is the first thing I'm doing is loading a Rhino logo from S3. And it's just NURBS geometry. And 3JS can't draw NURBS geometry. So I'm calling compute to get the meshes from the NURBS geometry. There's 6 of them here. And then there's some more geometry that I'm getting from another file, also using Rhino 3DM. And then I'm going to take, and there I'm calling up to compute to get the wireframe geometry, because that's not obvious out of a 3DM file either. And then I'm going to take all that geometry and send it up to compute and do a Boolean difference. The time that it's taking for this to disappear is how long it's taking for us to send the request and get the BREPs back. And now I'm meshing all that geometry and showing the result. This is, again, all running in the browser. Rhino's not running anywhere except for on an Amazon Web Services machine somewhere in Virginia. Okay? So, let's see. There's a way for me to get back here. I need to take a minute to talk about open source, because a lot of what we're showing today is possible because of the open source community. Emscripten and PyBind 11 are both really core technologies for providing the Python and JavaScript libraries. We're contributing all of this stuff back to the open source community because we think it's important to have easy to use open tools for representing geometry. And we've been doing open source projects for a while. OpenNURBS has been an open source project for a long time, but it hasn't been particularly easy for anybody to contribute to or get, or we haven't published new releases very well. So we're hoping to get better at that. You'll notice that all this new stuff is up on GitHub. There's all sorts of continuous integration built into it, thanks to Will. And so we're learning as we go along, and we want to know what's going to work well for you. One of the nice things about being where we are in this industry is that we get to talk to a lot of you, and we get to see you solving a lot of the same geometry problems and same workflow problems in isolation. And we're hoping that we can all work together to get some of these problems worked out so that you don't have to keep inventing the wheel in isolation. As a reminder, all of these projects are open source on GitHub. Please check them out. Thank you.